Welcome to today's class, Trigonometry class 10, and we will be discussing some questions related to this topic. Last class we have covered theory portion. This is the continuation class for the trigonometry. Do watch that before proceeding in this one. So now, the first question is, if sine A is 3 by 4, we have to find the value of cos A. And tan A. So we have to find the value of these both. Now, to understand it better, you can draw a right angle triangle, and this is the perpendicular. Perpendicular is 3 and hypotenuse is 4. Then from the formula h square equals to p square plus b square, we can find out the base, and the taking perpendicular as 3k and hypotenuse is 4k, we will be finding out the base as root 7k. As we have found out the base, so cos A equals to base by hypotenuse, so root 7 by 4. And tan A is perpendicular by base, which is 3 by root 7. This is A over here. So moving forward to the next question. It is given that 15 cos A equals to 8. So as cos A is 8 by 15, means base by perpendicular is 8 by 15 to base equals to 8 and perpendicular is equals to 15. So again, from the right angle triangle, we can find out the relations of the hypotenuse as h square equals to p square plus b square. That is the Pythagoras relation. And here 15 is the perpendicular and base is 8. So now the famous relation h square equals to p square plus b square, if we are taking bases at 8k and perpendicular at 15k, we will be getting that h equals to root over 289k square, which is 17k. Putting the value in the sine equals to p by h, means 15k by 17k coming out to be 15 by 17. And now again putting the value in sec equals to hypotenuse by base, which is equals to 17k by 8k equals to 17 by 8. Now, some questions from the important trigonometric relations. The most famous of them is the sine tail relation, cos relation, and the tan relation. On the basis of trigonometric angles, we have shared the trigonometric table. On the basis of angle, we have shared the trigonometric table, and in the last class we have discussed about that. So from there, we know the value of standard angles. So now tan 45 is 1, cos 30 is root 3 by 2, and sine 60 is root 3 by 2. I am implementing directly the trigonometric table. So the question is 2 tan square 45 plus cos square 30 minus sine square 60. Implementing the values in the respective places. So 2 into 1 square plus root 3 by 2 whole square minus root 3 by 2 whole square. This cancel out each other and we will be getting 2 into 1 as 2. So answer of this question is 2. Again, another question is sine A minus B is half, cos A plus B is half. So we know sine half comes for 30 degree. So sine 30 degree means half, and cos 60 degree is half. So a minus b is 30, a plus b is 60. So a minus b equals 30, that is equation 1, a plus b is 60, that's equation 2, adding the both equations. So a minus b plus a plus b, b minus and b plus cancels each out, and we are left with 2a equals to 90 degree. So a equals to 45 degree. If we are placing this value in equation 2, we will be getting 45 plus b plus equals to 60. Now 45 plus b equals to 60. So b is coming out to be as 15 degree. So a is 45 and b is 15. They simplify this question. Now coming to the next question. If sine square a, if 1 minus sine square a into sec square a equals to 1, we have to prove that LHS equals to RHS. We have to prove the identity 1 minus sine square a into sec square a equals to 1. We have to prove that this equals to this. So sine square a plus cos square a equals to 1. We have learned about the identities from the Pythagorean identity. This was the fundamental Pythagorean identity. So 1 minus sine square a equals to cos square a. So we are putting this value in its place. So 1 minus sine square a will be written as cos square a. So cos square a into sec square a. We have taken the LHS. So cos square a into sec square a will be coming as 1 because sec a equals to 1 by cos a, and if we are putting the value over here, to cos square a into 1 by cos square cancel out each other, and 1 is the result. Hence LHS is equals to RHS proved. Now coming to the next question. If ABC is right angle triangle and right angle at B, AB equals to 24 and BC equals to 7, we have to determine sin A and cos A. Again drawing the right angle triangle over here. So now AB, this one is B, it is right angled at B. This one is A, AB equals to 24, means base is equals to 24. This is A, and this is C, and BC equals to 7. We have to find the hypotenuse, which is AC over here, and it can be found out by the important relation called the Pythagorean relation. H square equals to P square plus B square. H square equals to P square plus B square. Using it over here, we know in the form of triangle AC square equals to AB square plus BC square. AC square equals to AB square plus BC square. Putting the value AB square equals to 24 square and BC square equals to 7 square. We are putting the value AB square equals to 24 square of 24, and BC is 7 square. Adding them, we are getting 576 plus 49. So AC equals to root over 625. So AC equals to 25 centimeters. So the hypotenuse is 25 centimeters. So sine, we have to find the sine. Sine is perpendicular by hypotenuse. So 7 by 25 is the sine. And cos comes to be as base by hypotenuse. So cos A equals to base is 24 and hypotenuse 25. So cos A equals to 24 by 25. Now, to understand this question, here A and B are acute angles such that cos A equals to cos B. We have to prove A equals to angle A equals to angle B. So now, this is angle A, this is angle B. So it is A, this is B, and this is C. The triangle is right angled at C. Triangle is right angled at C. This one is C. The triangle is right angled at C. Now, this for angle B, for angle B means cos B is BC by AB. BC by AB means base by hypotenuse. For angle B, this one is the base. And for angle A, this one is the base. This one is the base for angle A. This one is the base for angle B. So cos A equals to AC by AB. If both are equal to AC by AB equals to BC by AB, AB and AB cancel out. So AC equals to AB, BC. AC equals to BC. So if in a triangle, these two sides are equal, then this one is 90 degree, so these two sides are equal, hence this angle is equals to this angle. So angle A equals to angle B. Now, to evaluate this question, cot theta is given as 7 by 8. Now, I have to find the value of 1 plus sine theta into 1 minus sine theta divided by 1 plus cos theta into 1 minus cos theta. So, for the numerator, if I am multiplying with both, I am getting, this is A plus B and A minus B, means it can be written as A plus B bracket A minus B, sorry, A plus B multiplied to A minus B. This can be written like this. So, we know the value of this relation is A square minus B square. So, this is A and this is B. So, 1 is minus sine square theta, and from the Pythagorean relations, the fundamental theorems, fundamental identity theorems, we know 1 minus sine square theta is equals to cos square theta. Again, in the denominator, 1 plus cos theta, 1 minus cos theta, same relation applies. Hence, A square minus B square. So 1 minus cos square theta, that is sine square theta. And from the expression we know cot square theta is written over here as 7 by 8. Cot square theta is written as 7 by 8. And in the numerator it is, sine cos square theta, and the denominator it is sine square theta. So again, coming to the relation here, this is 8 and this is 7 from the relation of cot theta. This one is theta. So this is the hypotenuse. We don't need to find the hypotenuse over here because we need to find sine theta. Sine theta is 8 by h. Sine theta is 8 by h, and cos theta we have to find. Cos theta is 7 by h. Cos theta is 7 by h. And in the numerator it is cos square theta, and in the denominator it is sin square theta. So numerator is cos square theta, 7 square by h square, and the denominator it is sin square theta, so 8 square divided by h square. This h square and h square cancels, and the relation is coming out to be as 49 by 64. This is the relation, and this is the value. Means 7 by 8 whole square, and the relation is 49 by 64. Value of this expression. In the numerator it is only becoming cos square theta, and in the denominator it is only becoming the sin square theta. And so we have got the value of sin theta and cos theta. Putting them over here, we are getting the value of this expression as 49 by 64. Now, again, from the value of the standard angles, we have discussed the trigonometric tables for the standard angles of sin theta, cos theta, and tan theta. The standard angles were 0 degree, 30 degree, 45 degree, 60 degree, and 90 degree. And if we are able to recall any of the values of the sin theta, means the whole table of sin theta, if we are able to recall, we can find the whole trigonometric table from there only. So now, it is sin 60 degree, it is cos 30 degree, it is sin 30 degree, and it is cos 60 degree. So, sin 60 degree we know as root 3 by 2, cos 30 degree is root 3 by 2. Sin 30 degree is half, cos 60 degree is half. So now, root 3 here, root 3 by 2 into root 3 by 2 plus half into half. So root 3 by 2 into root 3 by 2 into half, we are putting the value directly over here. Sin 60 is root 3 by 2, sin 30, means cos 30 is root 3 by 2, sin 30 is 1 by 2, and cos 60 is 1 by 2. We are putting the value directly, and we are getting the next term as 3 by 4 plus 1 by 4. So now LCM is coming as 4, so 3 plus 1 as 4. So 4 by 4 cancels each other and becomes 1. So value of this whole is 1. Now, moving forward to some more questions. Here, sin A is 3 by 5. We have to find the cos A. Again, from the right angle triangle, if sin A is 3 by 5, the perpendicular is 3, hypotenuse is 5. We have to find the base for the cos relation. That could be found out by the important relation h square equals to p square plus b square. Here we don't know the base. We know the perpendicular as 3 and hypotenuse as 5. So putting the m in the relation, 5 square equals to 25 minus p means 9 square, sorry, minus p is 3, so 3 square equals to 9. From the relation is h square minus p square equals to b square, so 25 minus 9 equals to b square. It is coming to be as 16, which is equals to b square. 16 is coming to be as b square, and b equals to 4. b is equals to 4. So now base is 4 and hypotenuse is 5. The cos A equals to 4 by 5. In other term, we know 1 minus sine square theta means sine square A equals to cos square A. Cos square A. We know this. If we are implementing directly, then cos A equals to root over 1 minus sine square A. Putting the value as 3 of sine A is 3 by 5. So 3 square equals to 9, 9 by 25. 1 minus 9 by 25, 25 goes over here, LCM is 25. 25 minus 9 equals to 16. So root over 16 by 25, and cos A is coming to be as 4 by 5. Now, coming over here, tan theta equals to 4 by 3. Sin theta, we have to find the sin theta and cos theta. So tan theta, we know tan theta equals to sin theta by cos theta. Tan theta equals to sin theta by cos theta, and tan theta also equals to perpendicular by base. So now perpendicular over here is 4 and base is 3. We have to find the hypotenuse. H square equals to p square plus b square. So h equals to root over p square plus b square. So p is 4, so 4 square plus b is 3 plus 3 square. So root over 4 square plus 3 square is coming out to be root 25, which is equals to 5. So now we have to find sin theta and cos theta. So sin theta is perpendicular by hypotenuse. Hypotenuse is 5. So sin theta is 4 by 5 and cos theta is equals to base by hypotenuse. So cos theta equals to 3 by 5. So sin theta plus cos theta equals to 4 by 5 plus 3 by 5. And LCM, we are finding denominator as 5. So 4 plus 3 is 7. So relation of this, means expression is of this relation is coming out to be as 7 by 5. So sin theta plus cos theta equals to 7 by 5. Because sin theta equals to 4 by 5, as hypotenuse is 5, perpendicular is 4, and cos theta equals to 3 by 5. We know the value. Cos theta is 3 by 5, sin theta is 4 by 5. We are substituting the value over here. This 4 by 5 plus 3 by 5 equals to 7 by 5. This is the final result. Answer is 7 by 5. Now sec theta equals to 13 by 12. We have to find the sin theta. We know if the sec theta is 13 by 12, the cos theta comes out to be 1 by sec theta. Means we have to reverse it. This is hypotenuse by base. Cos theta equals to base by hypotenuse. So cos theta is 12 by 13. And we know important relation, cos square theta equals to 1 minus sin square theta. So putting it over here, cos theta, we are knowing the cos theta is 12 by 13, and putting it over here, the value goes, we have to find the sine theta. So sine theta is equals to 1 minus cos square theta, equals to 1 minus cos square theta. Sine square theta equals to 1 minus cos square theta. This is over square over here. Sine square theta equals to 1 minus cos square theta. So sine theta equals to root over 1 minus cos square theta. So we are putting the value of the cos square theta in this expression. Sine theta equals to 1 minus cos square theta. Cos square theta is 12 by 13. 1 minus 12 by 13 whole square, which is giving out to be 12 square equals to 144. 12 square equals to 144 by 169. And 1 minus in root over. It is coming, LCM is 169. 169 minus 144. LCM 169, so 169 comes over here. 169 minus 144 divided by 169. So expression becomes root 25 by 169. So 5 by 13 is the final result. 5 by 13 is the final result. So sine theta equals to 5 by 13. And here the bracket is missing. I have to put the bracket over here. This is the bracket required over here. So this sums our today's class. Hope you enjoyed today's class. Do comment, and if you have any suggestion, please recommend to us. How did you like the video? Please mention in the comment. If you have any query to ask the question, feel free to ask the question. And don't forget to like, share and subscribe my channel. Thank you.